about what, oh, all right. Just wanted to give you guys a little bit of background about where the data comes from. So I don't see any speech faculty here, but what we did was I grabbed some of the speech data. So there was a survey that the speech faculty deployed in their courses. And what they wanted to do was they wanted to, I guess, analyze the students' preparation for listening to a speech. So students were asked to kind of respond to what actions they did before they listened to the speech, during the speech listening session, and also what they did after listening to the speech. And so this was done, I believe, in the spring of last year, or spring of this year, I should say. And there were about 1,255 responses that were recorded from this survey. And so then what we've been hearing all morning is about what's really cool about this model is that now we're able to kind of combine this with some disaggregated data. And that's exactly what we did. We took the responses from the student survey and we combined them with their demographic data, such as their age, their ethnicity, their major, things of that nature. All right. And this is a little blurry, but this is kind of what the data looked like when I first received it. Just a hodgepodge of items. We have their major, the CRN of the course, their grade they received in the course. And also you're seeing a little bit of snippet of their responses to the survey questions, right? So in of itself, that really doesn't tell us a lot. When it gets really cool is when we start to break down that data. So as I start to show you different visualizations, I just want you guys to kind of just think of in your mind, and feel free to put something in the chat or unmute yourself. But as we go through these visualizations, just think of what kind of questions or insights will these visualizations of the data generate for you, okay? So in fact, the first one that we'll look at is the age distribution here, right? So this is a histogram of the age of the students and how many students are of that, particular age range. And I'll just give you guys a moment here and have you think about, is there anything that kind of stands out to you with this particular graph here regarding the ages of the students that participate in the survey? Anybody in particular? Let's see. Yeah, I can see I can see it in the chat, right? Overwhelmingly young, absolutely. As you can see, the vast majority of the students were 21 or younger in this data set. In fact, I was presenting this to my other faculty fellows this past Monday, and somebody remarked, it's like, hey, you should fix the scale on your graph because it looks like there's 15-year-olds taking this class. Well, believe it or not, there were 13-year-olds that were enrolled in some of these speech courses. So the ages range from 13, the youngest, up to 56, I believe was the oldest. So right there was kind of like the first, I think, shocking observation from the data. It's like we have an extremely young data set that we collected from here, right? Yeah, the vast bulk of the students were located in their 20s. Okay, so let's look at another visualization here. Okay, and so what you're seeing here is a scatter plot, and what we have along the vertical axis are the different ethnicities, right? So now we're kind of getting to that disaggregation, and then along the horizontal axis, you have the ages of the students. And the way that you kind of interpret this graph is that the deeper colors or deeper hues, that means a higher concentration or a larger number of individuals of that particular category. So once again, if you could take a moment and kind of just ideate, what type of trends are you seeing located here? Oops, go back. All right. I think one trend is certainly related to the age, right? That's a great question. So that's so some question asked about, are we looking at race or ethnicity? So that's a great question. So I need probably need to fix the slide, but that's kind of what I think Isis was talking about earlier, right? We need to get in and distinguish more. What do we mean by Asian and Latin and so on and so forth. But yeah, certainly there's once again, we see earlier that there's a concentration of younger students in the course. But as you tend to get the Hispanic ethnicity, we see a larger spread of the ages of those students, right? And similar with the Caucasians, but when you get to the Asians and maybe the multi-race, you're seeing a tighter concentration around the age group there. All right, I'm just gonna, yeah, exactly. Excellent. See, you guys are data experts. I'm out of a job. All right. So those are what I would call more rudimentary analysis of the data. And so what I want to do is I just want to once again thank the speech faculty for allowing me to get strange. Okay, so this is where it gets a little weird. I wanted to perform maybe like a deeper dive into the data analysis. And what I wanted to use was some artificial intelligence and some machine learning. And so the first thing I wanted to do was to use something called a decision tree. And so a decision tree is something similar to a flow chart, right? And what you would do, so a decision tree is a predictive modeling technique that's just like a flow chart. And so what I wanted to do is what you do is you feed the decision tree algorithm, you feed it in some of your data. So what I did was I had my data, I took randomly 80% of it, and I trained my algorithm on that 80% of that randomly selected data. And so what the decision tree was trying to do was I set it up so that it would input, well, it would take the inputs of the students' race, the students' responses to their survey, their major, and it would try to learn what the student's final grade was based off of all that information. So if you want to think of it, the inputs would be the responses to the survey, the demographic data, and the output, what it's trying to predict is that student's grade. So you take 80% of that data and you use that to train the model. And then what you do is you say, okay, here's 20% of the data that you haven't seen before, Mr. Decision Tree. Can you accurately predict what a student's grade would be based off of what you've learned during your training? And to my surprise, this artificial intelligence is almost scary. It was able to achieve 93% prediction accuracy on predicting a student's final grade based off of information it's never seen before. All right, so that was one really surprising thing, that this was actually a pretty accurate prediction model. Also, a really key component of this decision tree is that it has a feature called feature importance. And what that means is it tells us what are the most important attributes that you fed into the model that affect how it decided whether the student got an A, B, C, or D, right? So once again, this is called feature importance. And so what it was is that I found out that the model said, hey, the most important attribute or characteristic that affected how I decided what the student's grade would be, well, the first one was the age, right? And that's pretty obvious because we have so many young students, right? The second most important feature was whether or not the students were Hispanic or not. And then the third most important thing was, I think it was which course they took. So I said, well, this is geared towards, improvement strategies, right? So those are three things that we really can't improve, right? Or change at all, right? The student's age, what course they take, and things of that nature. So I said, okay, how about we look at what the algorithm deemed was the most important responses from the survey? And this is what I found out. So it said that when the student wrote notes, that was really important in determining how their final grade ended up. Whether or not they reviewed instructors' directions afterwards. That was a really important part. And then thirdly, whether or not the students were discussing their ideas from the speech with other classmates. And so those were the three most important questions from the survey that affected the students' final grade prediction. Now, what we have to be really clear here with what we're saying is that we're not saying if the student did these three things, they got an A. Let's be clear there. We're just saying somehow the algorithm said these were the three most important questions it used in determining the student's grade. Okay, so that was pretty cool. So then the next thing I wanted to do was like, okay, it would be really nice if we could take all of this kind of data and be able to cluster or collect the students into distinct groups. And then maybe we can have different improvement strategies depending on which group the students are contained in. And I think we were able to do that via what's called a cluster algorithm. And so this is what happened. So we ran all the data and we ran through the cluster algorithm, and it turned out that the algorithm was able to settle on 5 distinct groups of students within the data set. And so this graph is a little confusing because the axes are not really something we can interpret. These are combinations of all the variables. But all you need to know is that there's 5 different groups of students that this artificial intelligence was able to combine. Right, so you have your first group being the yellow group, you have your second group being the red group, and so on and so forth. Third group is the green group. Okay, so we have some type of consolidation of the groups here, right? And so then I said, all right, so we have these different clusters, right? Because each data point represents a student, right? We have these different clusters. Let's see if we can go in and kind of do some analyses on these clusters. Okay, so once again, as we start to look at these graphs now, I want you to think, what type of insights can we gain from looking at these graphs? All right. Okay, so this graph here is I went through each cluster, right? There's 5 clusters, and I went through each cluster and I said, for all the students in that cluster, what is the percentage of students in that cluster that received an A in the course, right? So clearly we can see that the first group, indicative of the yellow bar, they had the highest percentage proportion of A's, right? Over 80%. But then we noticed the third cluster had 0% A's. And so right there, I thought that was pretty cool. So this artificial intelligence was able to go in and say, listen, there is something going on in that third cluster where the students are not performing as well as the students in the first cluster. Right? And I think that's really impactful as we try to make our improvement plans, because now we can see there's something going on in that third cluster. All right. So next I said, all right, let's look at some of those questions. So remember there was three questions that the algorithm deemed was important to determine the student's final grade. Okay. So the first question we looked at is, did the student review the directions from their instructor? Once again, this is by cluster, the percentage. And so we can see that, once again, so your first cluster, the yellow bar, that's your higher performing student. Your third cluster, that is your green bar, that's your, we'll call them for lack of a better term, your lower performing students. We can see as far as reviewing directions, they pretty much did it on a similar scale there, right? So it's not the reviewing of the directions really that's making a big difference there. And then if we go to the next question, we asked the students, we solicited responses. We said, hey, did you discuss your speech, I guess, analysis with other students? And we can see that the yellow group did it at a much lower rate, right, which is the higher performing group, at a much lower rate than the lower performing students in that third cluster, that green cluster. And so I just want to take a minute. What do you guys think that means? Like, how would you classify, like, what do you think is happening here? And I'll tell you kind of what the speech faculty surmised, what they're seeing. Let's go back. See the chat populating a bit. Yeah, students have different learning needs, absolutely. Patrick, I see you're asking about the other factor. What's that? The third question?
Yes, Korea. Yeah.
Yeah, I just ran out of space on the slide.
Oh, okay.
But it was similar to they were pretty much the same percentages for both. And also too, Patrick, as a stats professor, you should know that the cluster 1 and cluster 3, they had a very similar sample size. They were about 250 students apiece in each of the cluster sizes.
Oh, good to know.
Yeah. All right. Exactly right, Cedar. That's what the speech faculty surmised. They said, listen, basically, for lack of a better term, the yellow group, those are your genius students. They said, listen, we're confident in this speech. We don't have to share it with anyone else, right? So I think that's what we were seeing there. So excellent. But yes, there's still going to be some ongoing analysis with this because I really want to get in. I haven't had time yet, but I really want to go in and see what's going on in that third cluster, do some more analysis of that cluster to see, okay, what's happening in that cluster that it's not allowing the students to connect well with the class. All right. So the next thing I was interested in, and we're getting towards the end here. The next thing I was interested in was let's do the ethnic breakdown per cluster. All right. So once again, I'm focusing on cluster 1 and cluster 3 because that's just the biggest, the most drastic change, right? So we have cluster 1, higher performing students, cluster 3, lower performing students. All right. And what we see here is that, and then this last column here, I'm giving you the distribution of the overall data set, right? So overall, 5.6% of all the students that participate in the survey were Asian, 15.4% were Black, so on and so forth. So I thought this was interesting just to kind of see how the clusters differentiate from the overall breakdown of the students that participate in the survey. All right. As we can see here, there's some percentages that are very similar, and there's some that there's pretty drastic difference, right? For Hispanic, right? The lower performing cluster had 40% Hispanic roughly. Cluster 3, the higher performing had, cluster 1 was higher performing. They had 40%. The lower performing had nearly 50% Hispanic. And so things along that nature. So I think this speaks to the strength of the model, right? I'm not sure if people were doing this before, getting this deep with their analysis and their assessment, but I think this is something kind of cool to look at and kind of ideate on and think about, man, what could we do differently here? All right. All right.
Anthony, I have a question.
Yes.
I see that Indian 0, 0, and 0.2. How did you get that 0.2?
Yeah, there were like, so the 0.2%, there were like, I think there were 2 Indian students out of a total of 1,255. So the overall is out of the total 1,255 students that participated. The 0% that you're seeing for Indian means that there were zero students in cluster 1, there were 0 students in cluster 3, which means the remaining Indian students must have been in the other clusters.
Other cluster, okay, thank you.
Yeah, just not in the ones that we grabbed for the analysis.
Okay, thanks.
Yeah, thank you. All right. So someone asked, how do you know the data is statistically significant for ethnic differences? Absolutely, that is the big question, and that's what I'm working on right now. There is actually a test. It's called the, gosh, I'm gonna butcher it. The Kolmogorov-Smirnov test, and what it is it's a non-parametric test, so we don't need a normal distribution or anything, and it's able to compare distributions and is able to determine if the distributions are statistically different or not. So that would be my next step here, is to determine, are these breakdowns statistically different from each other? Now we expect some differences because of randomness, but is there enough difference to say that these distributions are drastically different from each other? So great question. All right, let me see. Is there anything
Anthony,
else?
we do have a hand raise.
Okay.
My question was on Anthony, back to that chart, was that you have Indian there. Are you, when you say Indian, what are you referring, what group are you referring to?
That would be a institutional research question. I'm not sure. All I know is that I guess when they apply to the school, they just check Indian. I'm not sure what the breakdown would be for that, but that's.
Well, my question, I see Marie says native, but it could also, are you talking about Eastern Indian, Indian from India, right?
Yeah,
that would be my
yeah.
question, because if it were Native American, it would be.
What would they classify? And I would say too, that's one thing about the model, right? Your model's only as good as your data, right? So definitely I think that should spark the conversation. Once again, like Isis was saying earlier, we need to get in and further disaggregate, what does it mean to be Indian? What does it mean to be Asian, right? Maybe that can give us more insight. But yeah, but as far as how I collected the data, this is, I guess, what Valencia itself, this is what how they designate their ethnicities. Yep. Okay.
Thank you.
Yeah. Okay. So it looks like Marie was has put the answer to your question, Ada, in the chat. Yeah. So she is the expert. Yes. So any questions regarding that, she is the expert. All right. I think we have what, Carrie, one minute left.
Yes, yes,
Okay.
we have another minute, so you can entertain another question if you like. I'm
Hey,
gonna-
we got one more question. All right. All right.